So the idea started in the research lab at KU. We had found that tissues, the smaller a tissue was, when it was going to be transplanted, the better it typically did. And from that idea, we said, what if we forgot what an organ normally looks like? And we were just going to engineer organs so that they could work the best they could for transplants. What would it look like? And we tried 3 or 4 different things that all failed. And finally, a graduate student in my lab, who's now my partner in the business, he came up with an idea that efficiently was able to miniaturize tissues and organs so that they can be used for a variety of different applications.
One of the main things that kind of struck us was the first time we transplanted this into an animal. We found that within 24 hours, we had diabetic rats and they got cured. And it was exciting to know that something we had developed was able to do this. So when we're dealing on this, you're looking at stuff that could fit on a pinhead. It's a very small amount of tissue. You can actually see it by the naked eye when you're looking at it. It's a very small amount. A few drops of this would have thousands of these cell clusters. In fact, one of our molds that we use to grow these tissues, it's about the size of a silver dollar. It can grow 20,000 clusters on it. We will take out the pancreas, we bring it into our labs here. We will go through an enzymatic process where we subject the pancreas, we inject it and infuse it with these enzymes. It dissolves the tissue and we can pull out these clusters called islets. And these islets only make up about a percent of the pancreas. Once we can harvest this out, we can then take that apart into their individual cells.
By putting in the insulin-producing cells into the animal, there's no more insulin shots. Those cells start to produce insulin and they act as if the animal never had the disease in the first place.
Cats and dogs, the only offering that they have is daily or twice daily insulin injections. So in this case, it would be a once in 6 months, once a year injection that they would come in and get this, and it functions as a cure for diabetes.
We're screening for the pharmaceutical industry's new drugs. So they have compounds that they're interested in that they think might cure cancer or cure diabetes. We can screen those drugs on human miniature organs or human miniature tumors. So it gives the pharmaceutical company a better indication of, is the drug really going to work when it gets to humans?
I think one of the excitements about technology and a company like ours is we're really bringing a new idea to animal health.
It was really the robust resources around us in Kansas City that made us look at all of the applications we have for this technology and say, wow, we're in the heart of the animal health corridor here.
Animals unfortunately aren't offered all of these technologies as their primary mode of treatments. Many of these treatments on their way to human clinical trials are tested on animals, but never offered to them.
So it's a little hard sometimes to wrap your brain around all of the potential of this technology.